Hello everyone. Here we are going to discuss some of the numericals based on electric currents. So let us see what the numericals are. Basically we will be considering the formula I is equal to Q upon T, where Q depending on the number of electrons can be written as N into E, where N is the number of electrons and E is the charge on electrons. So based on that formula only we are going to discuss some of the numericals. Let us start with the first one. See, 10 raised to the power 20 electrons, each having a charge, passes from a point A towards another point B in 0.1 second. You have to find the current in ampere and you have to find the direction also. Now, very simple here. What you have to do is to find the amount of current. The formula for current is I is equal to Q upon T, where the value of Q can be written as N into E, number of electrons into the charge on the electrons. The number of electron is given here in the question. The charge on the electron is also given and the time is also given 0. If you solve it, you will get the value 160 amperes, 160 amperes. And naturally, as the electrons are moving from A to B, the direction of the current will be from B to A. I hope this is clear. We quickly move to the next one. Here it is asked that how many electrons per second flow through a filament of 120 volt and 60 watt electric bulb. Potential difference is 120 volt and 60 watt is the power given. So we have a formula, P is equal to V into I. Power is equal to voltage into current. So the value of current will be given by power upon voltage, that is 60 watt upon 120 volt. So the value which we get for current is 0.5 amperes. Now we have to find the number of electrons. So we have a formula for current which is written as Ne upon T. So the value of N can be written as IT upon E, or simply what we can say is like suppose the value of I is given by Q by T. So Q is equal to I into T, where the value of Q is Ne. So E comes to the denominator, so we write IT by E. That will give you the value of N, that is the number of electrons. And if we put the values of I, the time 1 second, then divided by the charge on the electron, and we have this value, which gives the 3.125 into 10 raised to the power 18 number of electrons are present. I hope this is also very clear. We move to the next one. In an hydrogen atom, an electron moves in an orbit of radius 5 into 10 raised to the power minus 11 meter with a speed of 2.2 into 10 raised to the power 6 meter per second. You have to find the equivalent current. The charge on an electron is also given. Now, to find the value of current due to a single electron, I is equal to Q by T, where the value of Q will be the charge on a single electron, so it will be E upon T. So we need to find the value of I, which is E upon T. Now see, 1 by T can be written as frequency, nu, and the value of T can be calculated here. T is the time period, distance moved in one complete cycle, that is 2 pi r, divided by velocity. So distance by velocity will give you the value of time period. So the value of r is mentioned there, 5 into 10 raised to the power minus 11, 2 pi into r divided by the value of velocity is given here. So the frequency will be given by, suppose we calculated the time period here, so the frequency will be the reciprocal of the time period. So whatever value we are having, we will take the reciprocal of the time period here. So the value of current now will be E upon T, that is 1 by T is nu, so we write E into nu, the frequency, and the value of frequency we have already calculated here. So the value of E, that is the charge on an electron, into the value of frequency here, and we calculate and we get the final value, which is written here in Armstrong. The unit taken here is Armstrong, which is 1 Armstrong is 10 raised to the power minus 10 meter. Again, I think this is also clear to you. We move to the next question. Look at the question very carefully. A graph is given between current and time, and you have to find the value of charge. Okay, time is 10 seconds given. You have to find the value of charge. Now, we know the formula Q is equal to I into T. Earlier also, we always know that when a graph is given, the area under the graph or the area under the curve represents the product of the two physical quantities given along y-axis and x-axis. So the area here will be given by I into T, and I into T we know is Q. So we need to find the value of Q, the charge, which is I into T, which is the area of this part which is given here. So this shape, we need to find the area which is covered by this curve. So area under the curve we need to calculate. So it is the area of a triangle into the area here of a rectangle or a square, whatever you can see depending on the values here. So the triangle here is area of the triangle, half into base is 5 into altitude is 5, so half into base into altitude, plus this area, this length here is of 5 seconds, so 5, 10 minus 5, this is 5, and this is also 5, so 5 into 5, this is 25, and here we take the value and we solve it. It comes out to be 37.5 coulomb. Very simple. So I think you all are clear with this. We move to the next one now. Here you see the amount of charge passing through a cross section of a wire is given here. Q is equal to AT square plus BT plus C, where Q is a function of time. You need to understand that here it is Q only. T within bracket represents that Q is a function of time. So you have to find the dimensional formula of A, B and C, and secondly you have to find the current. So let us do this. So what you need to do is, in class 11th you have studied, like when the physical quantities are added, their dimensions are to be same. Like the dimension of AT square must be equal to the dimension of Q. So see here, the Q has a dimension. Suppose the dimension of Q will be equal to the dimension of AT square. So the dimension of A will be dimension of Q divided by dimension of T square. So dimension of Q divided by dimension of T square. Q is I into T. I is current, so the dimensionally it is written as A into T is time divided by T square. So it cancels out. We have A T raised to the power minus 1. Similarly, BT, the dimensions will be exactly equal to Q. So the dimension of B will be Q by T. So we put Q by T, so it is A only. And lastly here, the dimension of C is directly equal to the dimension of Q, that is AT. In the second part, it is asked to find the current. Charge is given, so we write since the current is given by dq by dt. Here we are not writing Q by T because the value of charge varies as with time. It is not a fixed value. If it would have been a fixed value, then we could have written it as Q by T. Since it is not fixed, variable charge is there. So in that case, dq by dt is the better option, for which the small time interval dt, the dq charge is considered to be constant. That's why we can write dq upon dt. So the value of Q we are putting here. The value of A, B and C are given in the question. So we will put it and we will solve it. It's a simple differentiation only. And what we will do is we have to find the value of current at 5 seconds. So after calculating the value of I in terms of t, then we will put the values of A and B, and the value of t will be 5 seconds, and if we put it, finally we get the value, that is 53 amperes. So these are the very simple questions, the answer to which we have discussed here. I hope that everything will be clear. Any doubt, you can post me the doubts. Thank you.